All right, let's dive into something that's totally shaking up how our mobile networks get built. It's called O-RAN. And really, it's about tearing down the old, closed-off way of doing things and building something that's way more open, flexible, and honestly, just packed with innovation. So let's get right into it. So, have you ever stopped to wonder about this? I mean, when you build a computer, right, you get to pick the best parts. You grab a graphics card from one company, a processor from another, the whole deal. So, why haven't we been able to do that for the very networks our phones rely on every single day? It's a great question, and it's exactly the problem we're going to unpack. For a long, long time, this is kind of what mobile networks looked like. All the important stuff came from just one single supplier, all working together in its own little world. You bought everything from one place. But that convenience, well, it came with some pretty serious drawbacks. And that brings us to what people in the industry call the walled garden network. This was pretty much the standard for 4G and really every generation that came before it. What this means is a network operator basically had to buy the whole shebang, all the hardware, all the software, from just one company. This created a completely closed system, a situation called vendor lock-in, which made it pretty much impossible to bring in cool new gear from anyone else. And this quote from our source material just hits the nail on the head. This old model created a closed, and maybe most importantly, an uncompetitive environment. It kind of choked off innovation and left the network operators with very, very few choices. But that whole model is being completely dismantled. So let's talk about how the industry is breaking down those walls by, you guessed it, opening up the network. And the answer is O-RAN. It stands for Open Radio Access Network. Now, the keywords to remember here are open, virtualized, and disaggregated. It's all about breaking the network apart into individual pieces that can all talk to each other through standard connections, no matter who actually made them. Okay, and this really lays it all out, doesn't it? The difference is just night and day. We're leaving behind that old, single vendor, totally closed off, hardware-centric model. And what are we moving to? A world that's multi-vendor, open, standardized, and driven by software. It's not just a small change. It's a massive shift in how we think about telecommunications. So, if the network is now made up of all these different pieces, what exactly are those pieces? Let's take a look at the O-RAN building blocks. You know, the best way to think about it is that custom PC analogy we started with. Instead of having to buy a locked-down computer from one brand, O-RAN lets network operators shop around and pick the absolute best-in-class parts from a whole marketplace of different specialized vendors. Okay, so first up we have the OU, the radio unit. You can think of this as the antenna and the electronics right next to it. This is the part that does the heavy lifting with the radio waves, sending and receiving the signals that connect directly to your phone. Then you've got the ODU, or the distributed unit. This thing is kind of like the real-time brain of the whole operation. It does all the super intense processing required to manage the data flying back and forth and make sure everyone's connection stays fast and stable. And finally, we have the OCU, the central unit. This is the big picture strategist. It handles all the higher level stuff, like managing the overall traffic flow and connecting everything back to the main core network. And here you can see how it all clicks together. The ORU, the ODU, and the OCU all talk to each other over these standardized open interfaces. And what that means is, even if they're separate boxes from totally different companies, they work together like a single seamless 5G network. Pretty cool, right? But when you open things up like this and start mixing and matching parts from all these different companies, well, a new problem pops up. How do you make absolutely sure they're all going to play nicely together? And that right there brings us to the super important topic of testing. So yeah, this is the big catch. This amazing new freedom to choose comes with a new responsibility. You have to be able to prove, without a doubt, that a radio unit from vendor A can communicate perfectly with a distributed unit from vendor B. The solution is a process called conformance testing. And what you're seeing here is how it works. You take a single component, in this case an ORU, and you test it by itself. An emulator basically pretends to be the rest of the network, making sure that one part speaks the O-RAN language perfectly before it's ever allowed to join a real live system. So with this new way of building things and a solid plan for testing, what does this all mean for the future, for our connected world? Well, let's talk about why the future is, without a doubt, open. the payoffs here are huge. ORAN completely transforms the network, making it more open. It kicks innovation into high gear by creating a real competitive market. It gives operators the agility to roll out new features way faster. And of course, all that competition leads to some serious cost savings. And look, this isn't just about changing how we build networks just for fun. This open architecture is absolutely critical if we ever want to unlock the full, mind-blowing potential of 5G. Just take latency, for example. That's the delay in the network. I mean, look at this jump. With 4G, you're looking at a delay of around 10 milliseconds. But with 5G, which is enabled by architectures like ORAN, we're talking about getting that down to just 1 millisecond. That is a 10 times improvement that just changes the game entirely. That incredible near-instant response time is what's going to power the future. We are talking about services that really felt like science fiction not that long ago. Things like self-driving cars that communicate instantly with each other, surgeons operating from miles away using robotic arms, and entire smart cities running with perfect efficiency. So you see, ORAN is so much more than just some technical standard. It's really an open invitation to innovate. It shatters that old, closed system. And it leaves us with a really powerful question, one I want to leave you with. Now that the network is truly open and the basic building blocks of our connected world can be used by anyone, what are we going to build next?